Okay, so for the first thing, it says that when you suffer from an acid stomach, the fluid in your stomach can contain hydrochloric acid in a concentration of 2.5 by 10 to the negative 4 moles. To reduce the amount of acid in your stomach, you're advised to take an antacid tablet, which contains 5 milligrams of aluminium hydroxide and 5 milligrams of magnesium hydroxide. So this is a limiting reagent question. We know this because we've got too much information. Now the problem is that you've got both aluminium hydroxide and magnesium hydroxide. So in a sense, you're writing two equations. But that's too hard to manage with a calculation. So we're just going to use a simple equation. Hydrogen ions plus hydroxide ions gives water. So the number of moles of hydrogen ions here is equal to CV. So the concentration was 2.5 by 10 to the negative 4 multiplied by the volume of the stomach, which is 1.5, and this comes out to a number of moles of 3.75 by 10 to the negative 4 moles. Now we're going to find the number of moles of aluminium hydroxide and the number of moles of magnesium hydroxide. So the number of moles of aluminium hydroxide equals mass over formula mass, which is 5 by 10 to the negative 3. Remember, we have to convert to grams, divided by 78.004, and it comes out to be 6.409927 by 10 to the negative 5 moles. Now we know using this simple equation that we're looking at hydroxides. So let's find the number of moles of hydroxides, which is 3 times that number. And that comes out to 1.9229783 by 10 to the negative 4 moles. Now the number of moles of magnesium hydroxide is equal to mass over formula mass, which is 5 by 10 to the negative 3. Remember to convert milligrams to grams, divided by 58.326, and it comes out to 8.572506 by 10 to the negative 5 moles. So the number of moles of hydroxides here would be twice as many, which is 1.714. Now you need to find the total number of moles of hydrogen ions. Now this is a limiting reagent question, and you can see that the limiting reagent in a one-to-one equation would be hydroxide ions. So now you need to find the number of moles of excess hydrogen ions, and we do this by taking the number of moles of hydrogen ions at the start minus the number of moles of hydrogen ions used. So at the start we had 3.75 by 10 to the negative 4. We're subtracting how much we used in a one-to-one ratio, which will be the same as the hydroxide ions. And this comes out to be now this is moles, so we have to find concentration. So the concentration of hydrogen ions Comes out to 7.50 by 10 to the negative 6 molar. Using kW, (10 to the negative 14). So the hydroxide ion concentration is 1.33 by 10 to the negative 9 molar. Now for part B, it says if you took a second antacid tablet, what would be the hydrogen ion concentration, hydroxide ion concentration? So for part B, aluminium hydroxide dissolves in the hydrogen ions to give aluminium ions and water. And magnesium hydroxide does the same. But the key point here is that they are essentially insoluble and will only dissolve in the acid. So, because they'll only dissolve in the acid, as soon as there is no acid left, they are insoluble. So the hydrogen ion concentration at this point would equal the hydroxide ion concentration, which would be equal to 10 to the negative 7 molar.